First problem. A transmission line has the following primary constants per kilometer of the line. R is equal to 2.5 ohm, G is equal to 0.1 micromho, L is equal to 1.9 millihenry, and C is equal to 6.25 nanofarad. Calculate characteristic impedance, propagation constant, and velocity of propagation at frequency 800 Hz. Characteristic impedance Z0 is equal to root Z divided by Y, where Z is equal to R plus J omega L, which is equal to R plus J omega is equal to 2 pi F into L. When I substitute R, L and F in the above equation, 2.5 plus J 2 pi, F is 800 Hz, L is 1.9 milli Henry. Therefore, Z is equal to 2.5 plus J 9.55 ohm, which is equal to, in the polar form, Z is equal to 9.87 angle 75.33 degree ohm. Y is equal to G plus J omega C, which is equal to G plus J omega is equal to 2 pi F into C. Y is equal to G is 0.1 micro is 10 to the power minus 6 plus J 2 pi multiplied with frequency 800 Hz multiplied with C is given 6.25 nanofarad, 10 to the power minus 9. Therefore, Y is equal to 0.1 into 10 to the power minus 6 plus J 31.42 into 10 to the power minus 6. Therefore, Y is equal to 31.42 into 10 to the power minus 6 angle 89.82 degree is polar form of Y. Now I'll substitute the Z and Y answers in Z0 expression. Root of Z by Y is equal to Z0, which is equal to Z is 9.87 angle 75.33 degree divided by 31.42 multiplied with 10 to the power minus 6 angle 89.82 degree. After dividing 9.87 by 31.42 into 10 to the power minus 6, we will get 3.14 into 10 to the power 5. And angle 75.33 minus 89.82 is equal to angle 14.49 degree. Square root of 3.14 into 10 to the power 5 is 560.35. Square root of angle minus 14.49 degree is minus 7.245 ohm is equal to Z0. Square root of theta is equal to theta by 2. Now propagation constant equation root z into y. By z is equal to r plus j omega L. So we got z as 9.87 angle 75.33 degree multiplied with y. Y is 31.42 into 10 to the power minus 6 angle 89.82 degree. (9.87) multiplied with 31.14 into 10 to the power minus 6, we will get 3.101 into 10 to the power minus 4. After adding angle 75.33 and 89.82, we will get 165.15 degree. Therefore, propagation constant is equal to square root of 3.101 into 10 to the power minus 4 is 0.0176. Square root of angle 165.15 is 82.58 degree. Is propagation constant. Velocity of propagation notation Vp is equal to 1 by root Lc. One divided by L is equal to 1.9 millihenry. C is equal to 6.25 nanofarad. Therefore, phase velocity or velocity of propagation is equal to 2.9 and 10 to the power 5 kilometer per second. Second problem. A telephone line has R is equal to 6 ohm per kilometer, G is equal to 0.05 micromho per kilometer, L is equal to 2.2 millihenry per kilometer, and C is equal to 0.005 microfarad per kilometer. Determine Z0, alpha, beta at 1 kHz. If the line length is 100 km, determine the attenuation and phase shift of the signal. Calculate the phase velocity of the signal. In this problem, primary constants of the transmission lines are given. We have to find out characteristic impedance Z0, attenuation constant alpha, phase constant beta, and attenuation of the signal and phase shift of the signal, as well as the phase velocity of the signal. First, we need to find out characteristic impedance, that is notation Z0. Z0 is given by the equation root of Z divided by Y, which is equal to R plus J omega L divided by G plus J omega C. So therefore Z is equal to R plus J omega L, where R is equal to 6 ohm per kilometer plus J is equal to J and omega is equal to 2 pi f. F is 1 kilohertz, 1 into 10 to the power 3, and L is equal to 2.2 millihenry, 2.2 into 10 to the power minus 3. So which is equal to 6 plus J 13.82. Polar form of this is 15.06 angle 66.53 degree ohm. Now Y is equal to G plus J omega C. G is 0.05 into 10 to the power minus 6, 0.05 micro plus J omega is 2 pi, F is 1 kilohertz, C is 0.005 micros, 10 to the power minus 6, which is equal to 0.05 into 10 to the power minus 6 plus J 3.14 into 10 to the power minus 5. Y is in polar form, 3.14 into 10 to the power minus 5 angle 89.90 degree more. Now we can find out Z0 by substituting Z and Y value is equal to Z is 15.06 angle 66.53 degree divided by 3.14 into 10 to the power minus 5 angle 89.90 degree. After dividing 15.06 by 3.14 into 10 to the power minus 5, we will get root of 479.62 into 10 to the power 3 angle minus 23.37 degree we will get after subtracting the angles. 66.53 degree minus 89.90 degree is minus 23.37 degree. Root of 479.62 into 10 to the power 3 is 692.55. Root of angle minus 23.37 degree is minus 11.68 degree, which is equal to Z0. We know that propagation constant is equal to alpha plus j beta. We have to find out alpha and beta value. That's why first I'll find out propagation constant, expression root of z into y. We know the z value and y value. We will substitute here. Z is equal to 15.06 angle 66.53 degree, and y is equal to 3.14 into 10 to the power minus 5 angle 89.90 degree. After multiplying 15.06 and 3.14 into 10 to the power minus 5, we will get 4.73 into 10 to the power minus 4, and after adding angle 66.53 and 89.90, we will get 156.43 degree. Square root of 4.73 into 10 to the power minus 4 is 2.17 into 10 to the power minus 2. Square root of angle 156.43 degree is 78.21 degree. Propagation constant in rectangular form is 4.43 into 10 to the power minus 3 plus j 0.0212, which is in the form alpha plus j beta. Therefore, alpha is equal to 4.43 into 10 to the power minus 3 Napiers per kilometer beta is equal to 0.0212 radians per kilometer. Now we have to find out attenuation of the signal and phase shift of the signal. Attenuation of the signal is equal to attenuation factor into distance d, which is equal to attenuation factor is 4.43 into 10 to the power minus 3 Napiers per kilometer multiplied with distance 100 kilometer, which is equal to 0.4443 Napiers. Phase shift of the signal is equal to beta d. Beta is 0.0212 radians per kilometer d 100 kilometer, which is equal to 2.12 radians. Now we need to find out phase velocity. Is equal to omega by beta, which is equal to 2 pi f divided by beta, is equal to beta is 0.0212, 2 in the numerator, 2 pi, f is 1 kilohertz, is equal to 296.37 into 10 to the power 3 kilometer per seconds. Third problem, find the reflection coefficient and voltage standing wave ratio of a line having R0 is equal to 100 ohm and ZL is equal to 100 minus J 100 ohm. Reflection coefficient is equal to ZL minus Z0 divided by ZL plus Z0. So given R0 is equal to 100 ohm is equal to Z0. Therefore reflection coefficient, substitute ZL and R0 value. ZL is 100 minus J 100 ohm minus 100 ohm. 100 minus J 100 ohm plus 100 ohm, which is equal to minus J 100 divided by 200 minus j 100 is equal to 0.2 minus j 0.4. In the polar form, reflection coefficient is equal to 0.447 angle minus 63.43 degree. Voltage standing wave ratio is equal to 1 plus magnitude of reflection coefficient divided by 1 minus magnitude of reflection coefficient. This is equal to magnitude of the reflection coefficient is 0.447 divided by 1 minus 0.447. Therefore, voltage standing wave ratio is 2.616. Fourth problem. A load impedance of 500 ohm is connected to a transmission line of length 200 km. The characteristic impedance of the line is 700 angle minus 20 degree ohm. Determine voltage reflection coefficient. Given ZL is equal to 500 ohm, Z0 is equal to 700 angle minus 20 degree ohm is equal to 657.78 minus J 239.41 in the rectangular form. We know that voltage reflection coefficient is ZL minus Z0 divided by ZL plus Z0. Therefore, reflection coefficient is, I substitute ZL and Z0 here. ZL is 500 minus 657.78 minus J 239.41 divided by 500 plus Z0 minus J 239.41. Therefore, reflection coefficient is equal to, after ZL minus Z0, we will get minus 157.78 plus J 239.41 divided by, after ZL plus Z0, 1157.78 minus J 239.41 is equal to minus 0.089 minus 0.22 J. Therefore, reflection coefficient in polar form is 2.237 angle 112.02 degree. Fifth problem. A 50 ohm lossless line connects a signal of 100 kHz to a load of 100 ohm. The load power is 100 milliwatt. Calculate the voltage reflection coefficient, VSWR, position of the first V minimum and V maximum, impedance at V minimum and V max, and values of V minimum and V max. Given Z0 is equal to characteristic impedance is 50 ohm, frequency is equal to 100 kilohertz, and ZL is equal to 100 ohm, and load power PL is given, it's 100 milliwatt. Now we have to calculate voltage reflection coefficient. The reflection coefficient is equal to ZL minus Z0 divided by ZL plus Z0, which is equal to ZL 100 minus 50 ohm divided by 100 plus 50 ohm. Therefore, reflection coefficient is equal to 1 by 3. Now we have to find out VSWR, voltage standing wave ratio. Notation is rho or S, which is equal to 1 plus magnitude of reflection coefficient divided by 1 minus magnitude of reflection coefficient, which is equal to 1 plus 1 by 3 divided by 1 minus 1 by 3. Therefore, VSWR or rho is equal to 2. Now we have to find out the position of the first V minimum and V max. For real ZL greater than Z0, first V max is located at the load. First V minimum and first V minimum is located at a distance lambda by 4. So what is lambda? Lambda we can calculate by equations C by F, where C is 3 into 10 to the power 8, F is given, it's 100 kilohertz, therefore lambda is 300 meter. Sorry, lambda C is 3 into 10 to the power 3 into 10 to the power 8 divided by 100 kilohertz is equal to 3000 meter. Therefore, lambda by 4 is 3000 meter divided by 4, which is equal to 750 meter. Fourth question in the fifth problem is impedance at V minimum and V max we have to find out, and values of V max and V minimum. At V max, impedance is equal to VSWR into characteristic impedance is equal to 2 into characteristic impedance is 50 ohm, is equal to 100 ohm. At V minimum, impedance is equal to characteristic impedance divided by standing wave ratio, which is equal to 50 divided by 2 is equal to 25 ohm. Value of Vmax we have to find out. For that, I have PL value, so I'll use the PL equation, load power equation. PL is equal to square of Vmax divided by ZL, which is equal to 100 milliwatt. From this equation, I'll find out Vmax. From the PL equation, I can find out Vmax, that is equal to PL is equal to square of Vmax divided by ZL. Therefore, Vmax is equal to square root of PL into ZL, which is equal to PL is 100 milliwatt, that is 100 into 10 to the power minus 3. ZL is 100 ohm. Therefore, Vmax is equal to root 10 volts. Now, value of V minimum I can find out by the Vmax value, that is Vmax divided by standing wave ratio, which is equal to root 10 divided by 2 volts. Sixth problem. A lossless transmission line with characteristic impedance of 300 ohm is fed by a generator of voltage 0 degree volts and impedance 100 ohm. The line is 100 meter long and is terminated by a resistive load of 200 ohm. Calculate the reflection loss, the transmission loss, and the return loss. Given generator impedance 100 ohm, characteristic impedance 300 ohm, length 100 meter, and load impedance is equal to 200 ohm. To find out reflection loss and transmission loss as well as to find out return loss, I have to find out reflection coefficient. Reflection coefficient is equal to ZL minus Z0 divided by ZL plus Z0. ZL is 200, Z0 is 300. 200 plus 300. Therefore, reflection coefficient is equal to minus 1 by 5. Reflection loss is equal to ten log of 1 divided by 1 minus square of reflection coefficient, which is equal to 10 log of 1 divided by 1 minus 1 divided by 25. This is equal to 10 log of 25 by 24, which is equal to 0.1773 dB. Transmission loss is equal to attenuation loss plus reflection loss. Attenuation loss is 0, reflection loss is 10 log of 1 divided by 1 minus square of reflection coefficient, which is equal to 10 log of 1 divided by 1 minus divided by 25, which is equal to 0.1773 dB. Return loss is equal to minus 20 log of reflection coefficient, which is equal to minus 20 log of 1 by 5 is equal to 13.98 dB.